In the black depths of the ocean lies a toxic pool that can kill organisms in an instant. This pool is so poisonous that it can even melt steel. Yet paradoxically, death becomes immortal here forever. But what is it doing in the deep sea? I mean, just look at it like this. In the middle of the ocean, which is already made of water, there's a lake at the bottom, complete with its own beach. But how? Actually, this underground beach is more of a graveyard. Scattered here are the carcasses of creatures preserved for years. For example, the body of this crab has been preserved for 8 years. But how can a lake that melts steel also preserve a body? Well, the poison in this pool is salt. These are also called brine pools, and they are some of the most extreme environments on Earth. These lakes are saltier than the Dead Sea, saltier than any ocean you've ever swum in. In some cases, their salinity exceeds normal seawater by 8 to 10 times. This extreme salt concentration makes the water incredibly dense. But while they look calm and peaceful, these underwater lakes are actually lethal. Their waters kill everything that enters them. The boundary between the brine pool and the surrounding seawater is literally the boundary between life and death. Anything that crosses it dies. One moment a fish is gliding across the seafloor. The next it crosses an invisible line and its body chemistry collapses. Fish brains need oxygen to function, but brine pools contain almost no oxygen at all. Instead of breathable water, animals encounter hypersaline liquid loaded with toxic chemicals. Imagine putting 5 to 10 spoons of salt in your mouth at once. Burning, thirst, and instant dehydration. For any fish, this salty lake is a toxic cocktail of hydrogen sulfide, methane, toxic metals, and zero oxygen. Through osmosis, water is instantly sucked out of the cells. The body dries up from the inside, and the lack of oxygen leads to hypoxia, lung failure, and organ shutdown. The combination of hydrogen sulfide and metals hits the system like a 400-volt electric shock, causing muscle twitching and instant death. Then, the corpse settles in the pool. With no scavengers, no flesh-eating bacteria, and no air, only desolate silence. The high levels of barium and sulfate create a barite coffin around the bodies, preserving them for decades. But the biggest mystery isn't how these lakes kill. It's how they exist at all. How can a lake survive inside an ocean without mixing? The answer lies in Earth's geological history. Millions of years ago, many of the seas we know today were completely cut off from the global ocean. The Gulf of Mexico, the Mediterranean Sea, and the Red Sea. When these basins became isolated, their waters slowly evaporated, but the salt remained. Over time, thick layers of ancient salt formed across the seafloor. Later, these salt deposits were buried beneath sediment and rock. As tectonic forces reshaped the planet, the pressure caused the buried salt beds to crack and deform. Seawater began seeping downward through these fractures. When the water reached the salt deposits, it dissolved them, turning ordinary seawater into extremely concentrated brine. Heated by the warmth of the Earth's interior, this dense salty water slowly rose upward again. But because it was much heavier than normal seawater, it settled back down to the seafloor, pooling in natural depressions and valleys, forming vast underwater lakes. Some brine pools are only a few meters across, others stretch for miles. In the Gulf of Mexico, certain brine basins are so large that underwater waterfalls form within them. But despite their deadly chemistry, these lakes are not completely lifeless. In fact, they support some of the most unusual ecosystems on Earth, because around the edges of these toxic pools, life finds a way. Tiny microorganisms called extremophiles thrive in these extreme conditions. Unlike most life on Earth, they do not rely on oxygen or sunlight. Instead, they use chemical reactions to produce energy, a process known chemosynthesis. These microbes feed on methane and sulfur compounds released from the brine. Just as plants convert sunlight into energy through photosynthesis, these microorganisms convert toxic chemicals into food. And that chemical energy supports entire ecosystems. Around the borders of brine pools, life begins to flourish. Colonies of tube worms stretch across the seabed. Dense beds of mussels cluster along the shorelines. Shrimps, crabs, and strange deep-sea animals gather to feed. Predators lurk nearby. waiting for unlucky creatures that fall into the toxic water. Two very different worlds exist side by side. One side is a chemical death trap. The other is a thriving oasis of life. This strange contrast has fascinated scientists for decades, because environments like this may hold clues about the origin of life itself. Billions of years ago, Earth's oceans were very different than today. They were poor in oxygen, rich in methane, and extremely salty. Conditions are remarkably similar to modern brine pools, which means these underwater lakes may resemble the environments where life first began. Natural laboratories that recreate the chemistry of Earth's earliest oceans. But the implications go even further, because these extreme environments may also resemble places beyond our planet. Scientists believe several moons in our solar system contain vast underground oceans. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. Beneath their frozen surfaces lie enormous oceans of salty water hidden in darkness. And if life can survive in the toxic depths of Earth's brine pools, then something might be living in those alien oceans too. Yet despite centuries of exploration, humans have barely begun to understand our own planet. More than 95% of the ocean remains unexplored, which means somewhere down there, in the darkness of the deep sea, there may be more hidden lakes, more strange ecosystems, and perhaps entirely new forms of life, waiting silently beneath the waves.